Now, as we were discussing kurtosis and skewness, we discussed that we were trying to measure them using software. So, I told you that we will go through a software and try to find out. As we can see, we have our keyword installed here, we have the teaching tab here, we have imported the files. Okay. Now, after importing the files, this is the data which we get, the my CSV data. Now, we go to teaching, we go to descriptive statistics, we go to statistics. In statistics, we click all these things, okay. Arithmetic mean, median, mode, max, you can read, okay. Variance, coefficient of variance also, and the variable we are interested in. Suppose we are interested for 2 variables and we submit it, okay. Now, as you can see here, the coefficient of skewness is negative and the coefficient of kurtosis is positive. Now, what does that mean? Let us see the histogram. Yeah, just a second. So, we go to plot, yeah, histogram, and let us see JP01. Okay. Okay, so now we will go and see the histogram. See, so as you can see, obviously any Likert scale data will not be having completely a normal thing, but what you are trying to say how much normal it is. So, as you can see, there is little, what we say, concentration of effort of values around 374, and let us open the slides and see that what is the kurtosis and skewness coefficient should be. Okay. So, as you see, we have a positive coefficient of kurtosis here, and that is, you see, leptokurtic. So, the data seems to get centered around, the peak is observed, okay. The peak is there. So, the standard deviation is decreased, okay. So, standard deviation is decreased around the mean. In pretokurtic, the standard deviation increase around the mean. So, when the data is like this, so not only it is skewed, and as you can see, it is forming a negatively skewed value. You can see, as our graph says, this one. In that way, we can find it that this is negatively skewed. There is another way, you can see mean is less than median and less than mode. So, we have got the mean, we have got the median and mode are same. So, mean is less than median. So, mean is less than median, it means negatively skewed. So, we have got negative coefficient of skewness in this case and positive coefficient of kurtosis, which is leptokurtic. Okay. So, 2 things we have got. Now, this depends that how much standardization you need. So, there are tolerable limits, and that depends from data to data, okay. And that we will try to demonstrate when we do the last week, when we are trying to combine everything, that how practically we do all these things, okay. So, this is what's normality. So, we have measured normality, we have defined what is normal plot, what is z value, okay, the CDF of z values, normal plot, and skewness as kurtosis. The skewness and kurtosis are actually, if you remember again, the moments. So, these are also measures of variability, okay, but I did tell you that we will discuss this more in detail when we will try to cover the part on normal curve. So, with this, our understanding of normal curves is finished, okay, and this is the last thing which we have to show, which we will see in images, okay, and I will just enhance this. So, now this is very important, and we will testify this. So, between 2 standard deviations, one from mean low, one from mean up, we have got 68% of data covered up. Okay. Now, how will we check that? Now, again we will check that. Let us see, here we go and we select this one, okay, minus x to x. So, between this and we put 1. So, you are getting 68%. Okay. So, from minus 1, so this is from minus x to plus x. So, minus 1 to plus 1 is 68% of our data. Okay. Similarly, we can see for 2. Okay. So, actually if you enter 2 here, you will get 95.45. So, 2 sigmas, 1 minus sigma here and minus 2 sigma here, minus 2 sigma this side. Okay. And if you go for 3 sigma, you can see 99.7% of data. So, 99.73. This is the sigma we are talking when we discuss in operations and quality improvement 6 sigma. So, these are levels of sigma. I am not saying this 3 sigma is that sigma. Okay. So, this is that thing, that the range of data of the data is covered between 1 sigma is 68%, 2 sigmas or 4 sigmas is the range is 95%, you have 3 sigma on the both side, you have 99.97% data. With this, our class on the normal graphs ends, and now we will continue with sampling. Thank you very much.